Okay, so I'm going to basically collapse that for starters. Okay, so we're going to start off with the Esp IDF. So once again, let's get cracking. All right, so this is essentially Esp IDF code. Okay. Now what I've done is I've actually, when you actually create an Esp IDF network capability on the ESP chip, there's a lot that you need to consider specifically for production, and there you wind up writing about 100 lines of code just to actually get the connection in place, okay, and to get everything sort of interlinked and working. So that sort of interleads to a little bit of a problem. What if I just want to get started? What if I just want to basically do something without having to actually worry about I just want to prove a concept? Well, if you have a look at this particular code, right, it's essentially 34 lines long. It's not hundreds of lines long, so there is a way to do that. Okay, now the way that we actually do that is we basically delegate all the connection capabilities over to a module that's already sitting inside the Esp IDF. Okay, it's called this thing over here. It's called example connect. Okay, so how do we reference that particular example connect? Well, if we have a look at our CMake lists on our root directory, which is essentially, if you're not familiar with the CMake lists, it's a thing that links everything together. It's the thing that actually starts to actually build everything, right? These few lines of here are comments, and then essentially it basically puts some revision data in it, okay? And then after that, it basically does a couple of things. Firstly, it says this is essentially the directories that we're interested in it, and if you have a look at that's pointing to the IDF path, okay? And that's basically looking at some protocol comments. So this particular line of code, these lines of code over here, in fact, all of these lines of code that you see over here, without this one, oh sorry, all of these lines of code that you see without this set over here, okay, are boilerplate. You basically put that in every single directory. If you have a look at the starter template that I created, it's in there. You don't need to worry about it. You just basically add it in the root and it's all good. Nothing to worry about. The thing that's different, the thing that's actually new here is basically this line over here, set extra components. And this is a kind of import. Think of it like in a C# where you're using, or if you're using Node.js require. This is what that does. That basically brings in this particular example folder. So if we go ahead and have actually a look at that. So on my C drive, I have my ESP directory over here. Oh, that's why. All right, it's in here. So IDF, common, examples, common, components. So this is essentially what it's looking at. So you can go inside this particular directory and you can have a look at how it's actually connecting, okay? And if you have a look, here's that 100 lines of codes I was telling you about, okay? We won't be doing this for every single line of code, but you can get an idea as to what's going on and you can have a look at that if you so desire to. So this is what this line is actually pointing to. Once that's involved, then you can basically add this header file, okay, which is essentially just example connect. And then you can basically use this example connect over here. Now, let's have a look and see what actually is going on here. For starters, we basically flash our NVS, our non-volatile storage, or we just initialize, sorry, we initialize our non-volatile storage. And the reason why we initialize our non-volatile storage is because the Wi-Fi keeps a bunch of different settings inside NVS. Okay, so it needs those for the wireless, right? Then we have a TCP/IP adapter, which it then goes ahead and initializes. So we don't have to worry about that level of communication stack. It does it for us. Then we got something called ESP event loop create default, okay, which is basically just creating an event loop, and we'll basically have a look at that in a while. And then up to here, it goes ahead and just connects, okay. Now, that is in essence the code that you need in order to connect to a wireless device. That's it. That's about 5 lines of code, okay. Most of the heavy lifting is done inside the example connect. That'll actually give me that'll give me an IP. Now the rest of it is a little bit sort of just me mucking around. What I'm basically doing is I'm creating a client, okay, and I'm saying the URL is Google. An event handler is essentially given to me when I actually hit that client. In other words, what's going to happen when I actually reach that client. And you can see over here that this event handler, client event handler, is essentially this thing over here. You can consider it like a callback, which is exactly what it is. And this callback, what it's basically doing is it's got a couple of different switch statements, and we can have a look at the various different switch statements that it's going through when it's doing its connection. There's a whole bunch of different ones, and we'll have a look at that in a bit more detail later. But once we actually get data, right, then we can do something with it. And at this point in time, I'm actually just printing it out, okay? So now, if you're interested in using something like, if you're a web developer, and I know a lot of the guys here are developers, if you're interested in doing something like, if you're used to doing something like fetch, or like a HTTP require or something like that, you kind of think to yourself, all right, well, I've got a URL and I've got a callback function that will basically give that to me, which is very similar to like fetch. Okay, think about like fetch URL, and then essentially I get a promise back, and then I can do something with that promise and then get the body of the JSON, whatever. What about things like headers, passwords, gets versus posts and stuff like that? If you actually have a look at this particular definition of the structure, you'll notice that that's actually all in here. So you can put certificates in here, you can have username and passwords, you can put in, as you see, the URL, the host, the various different other thing, and you can basically say whether it's a get or post. You can do certain things like that. Okay, but to keep it simple, I'm just basically trying to get out to Google, and then essentially this thing over here triggers the callback, so essentially that initializes everything, and then we're pretty much on our way. So if we actually have a look at this guy, let's have a look and see what it does. So we'll say idf.py. Oh, there's something else, and that is important. Okay, what about connecting to the wireless? Okay, I'll show you how that works. The example connect, if we have a look at that directory, it's got this thing called kconfig.projbuild. This is how you build custom menus within the IDF. I'm not going to go through all of that now, but what I will show you is essentially if I open this up, so I'm just going to copy the path, and then I'm going to open up the Esp Idf command prompt. Okay, and I cd into that directory, and then I do an idf.py menu config. So those of you who don't know, idf.py menu config. For those of you who don't know, the IDF comes in with a built-in configuration system, and this is what it looks like. Okay, and you can basically put any strings or anything else you want, and then you can access those things in code. And you'll notice over here we've got this example connection configuration. So essentially, if I go into that, that's basically giving me a Wi-Fi SSID and password. So that's essentially what it's using behind the scenes, the example connect, to basically know where we're at in terms of the wireless. Okay, so now that that's done, let's go ahead and try this out. So idf.py flash monitor. Okay, and what we can expect to see is, firstly, it's flashing the device. So I've got my device over here. It's flashing it. Obviously, if it hasn't built it, it'll build it first.
Do those credentials have to be like static data, or can you enter them somehow?
You can enter them any way you like, and we'll have a look at that a bit later.
So can you enter them?
But before you go on, have a look at this. Okay, so now you can see that we've got an IP address. Okay, all right. And now it's basically reaching out to Google, and you can see that we have the actual redirect, and it actually redirected for us, and that's the actual Google page. So if you're very good at reading HTML and very fast at it, that's what Google page currently looks like. Okay, and there you have it. Essentially a very, very simple client. Okay, in about 13 lines of code. Okay. All right. Huh? Not formatted. So yeah, I've got one of my sort of lead front end guys over here. Could you please fix the CS over there?
This is not WC3 compliant. This Google homepage.
So if that was a not a 200 response, would your handler still get called?
My handler would still get called, but I might, yeah. So look, I mean, if it's a valid response,
Or was it 300 whatever?
Yeah.
That would still your handler get called for that.
yes, that's right. So the handler handles that. It handles the redirect. It'll handle the redirect.
Falls out of that, and then the code takes care of the redirect.
Now, something worth of well, actually, this client, this particular client, is actually a pretty high level client. So this particular client that we're looking at over here is actually already quite high level. It's built on something called LWIP, which is essentially another stack used for embedded devices to talk to the internet. And over there, you've got much lower levels. You can go down to the TCP/IP level. Okay, but who the hell wants to do that? Okay, so that's so one thing that is interesting and something that does happen is the actual buffer the buffer that's actually get brought back is pretty small. And what you'll find is that if you actually put a breakpoint in this, I don't have my JTAG here, but if I put a breakpoint in this, what you'll notice is that it actually chunks it. So it gets, like, I don't remember how big it is, and it's actually configurable. You can get so many bytes, and then you can wait, and then it'll basically go out and get the next lot of bytes, and it'll go out and get the next lot of bytes. So you know, if you're dealing with large amounts of files, you can basically malloc them and put them into storage or whatever. It's not like you have to deal with the whole chunk at once. Okay, so that's something else that is of interest. Okay, cool. So there we have the minimal client connect for the ESP-IDF. All right. Now, what I'm going to do now is I'm going to open up platform.io. Anybody over here using platform.io? No? Okay. So for the Arduino users, it's something that you probably might want to consider, okay? Because it basically comes with the Arduino, it comes with full Arduino support, including things like IntelliSense and everything else like that. It knows how to do it. You can basically open up the you can configure the dev boards from here. You can do anything you want to from here. The only difference is that it prefers, you can use INI files for Arduino, but it actually prefers to use C++ ones. So over here we've got an Arduino client.
Is there any benefit of using platform.io than just using the VS Code?
Visual Studio or VS Code?
Yeah, Visual Studio. I mean, without the...
There are definitely some advantages. For starters, it's totally free and it's got all the debugging built into it. Okay, so it's got all the OpenOCD stuff done in it. It's got a very large community support. And one of the things I actually really like about it, right, if I can get it to work, is the fact that it does some clever things with relation to compiling. It seems to cache a lot of stuff. I don't exactly know how it works, but I find that it's the fastest thing to build projects with. Okay, let's just try this one more time. Open project. So this is the client. That looks better. Okay, so you get a whole bunch of other stuff behind the scenes here. Now, I'm a big fan of the IDF, and I would prefer to use my template because I find it's less magic. Platform.io has got, like Visual Studio Code, has got some magic in it, and that scares me because when things go wrong, I don't know how to debug that stuff. Okay, and things go wrong. This is microcontrollers, as you saw when I first arrived here. Okay, but let's have a look at this guy. All right, so very simple, right? Even though you notice that this is a C++ file, the only difference between it and an INO file is it's got this Arduino.h at the top. Otherwise, everything else is the same. It's got a setup, it's got a loop. Okay, in the setup, you basically have, okay, so we need to actually change the wireless composite. So this is CCHS, and it's, what is it? HECMELB. HECMELB. Is that right?
Yeah.
Yeah. Okay. So it's printing a whole bunch of lines. It's basically getting some stuff, Wi-Fi, and then essentially it tries to connect, gets a local IP, and then it goes ahead and does a loop. Okay. Now there's a couple of things I don't like. You saw how I actually did my client. I don't like this as much. I'm not sure if there's a better way to do this with the Arduino. There might be. And because the Arduino is built on the ESP-IDF, you could probably import those libraries that I was just showing you. But if you have a look at the way that this is configured, first you can't basically talk directly to a URL. You actually have to connect to an IP address and a port, which is kind of ugly. Okay, so over here I've got the IP address for Google. Okay, and then if it all works, then essentially you've got to actually do this, which is nasty.
I think you can actually connect to the URL
Okay, I haven't tried it. I'll just look at it. Okay, cool. Well, that'd be something to try
I
out.
think because it's using the ESP as well.
I just, yeah. But yeah, let's go ahead and actually give this a try. Now, as I said, this thing is a bit more magical. I'm used to writing commands, but in essence, what we'd have to do to get this to work is first I click on this button, which uploads it. And watch, you'll notice, right, this is I've just changed it, right, I'm not sure if it's a fresh build, but it is pretty fresh. It's already actually dumping it into the chip. It's pretty quick, okay? I have noticed that even fresh projects are fast. They're pretty good, okay? It's actually recently gone open source. You had to actually pay for things like debugging features, but now they've actually made it open source. Now over here, right, because we're not writing IDF, Flash, and Monitor on the same command line that we were writing before, right, we have to actually open up a terminal. Just one thing, the default, because it's built for Arduino, right, the default is not 1152, so you'll have to set that, otherwise you get a whole bunch of garbage out. And once we actually connect to it, waiting for Wi-Fi, it's got an IP address, and it's got a status 200. You notice that I didn't get the entire payload back. I didn't figure out how to do that in time, but I'm pretty sure you could figure it out.
It's like a serial object, so you can just write while the client.available.
Reading the stream.
Okay, so you get a serial object back and you just write it. Okay, cool. All right, cool. So there you have the Arduino equivalent. Okay. Just make sure I close these ports, otherwise my next project's not going to work. Okay, so I'm going to close that. All right, so that is the connect. Okay, that is just actually me going out to the internet, doing a REST call, getting you know, some sort of client, something or other. Not too hard. All right. All right, so let's have a look at this one. IF.py. All right. Flash. Let's see if this works. Monitor. I'll run this first, and then we'll basically
Just spelled monitor.
monitor. Okay, so that is almost finished compiling, so that's not going to take very long. Okay, so while that's actually busy, let's go ahead and have a look at the source. So CMake lists, right at the top, off the bat, I've got the sorry, not CMake, yeah, CMake list.text. I've got that same example import that I had before. Okay, and then if I have a look at main.c, okay, what you'll notice here is something very similar. So we can see that we've basically got NVS Flash, the adapter, the event loop, all right, and then we connect with example connect, and then after that we start a server. This is how we do a server. We say HTTP D start. Okay, D stands for daemon, which basically means that this thing is going to run in the background on its on its own task. I was about to say thread, but it's not a thread, it's actually a task. All right, and then, hope I can get rid of that. Okay, and then what actually happens is we do the following, all right? Whoever here has actually worked with things like Node.js or Visual Studio equivalent, where you set up, let's say, an MVC route or MVC controller for Web API. Has anybody done that? Or a Node.js, where you basically have... Yeah, you basically separate your path, and every single language has got something similar, whereby you basically say, this is the URL I want you to listen to, and there's a callback function that is associated to that particular route. In MVC case, it's normally an attributed function or something like that, okay? But in essence, this is what this structure is trying to say. It's trying to say, when you hear something on this particular URL, and it is an HTTP GET, then you call this handler. This is the callback, all right? And then you just register the thing. And this handler over here looks a bit like this. Over here, I'm just logging out something saying, hey, I got hit. Then I'm basically creating a message, and then I do a response. Send the message, okay? Now, if you have a look and see, I've already started this particular one. If you have a look over here, you can see that I have here, this is the IP address that it's gotten for the server. That's given to me automatically. Okay, and you can set that in your configuration, right? Where you go ahead and actually set all this the connect. We don't do it in this particular case because we were using the shorter version, but where we can actually set up, where we can actually do the longer version, you can actually set up the URL, and I'll have a look at. I'll show you that a bit later. Hey, somebody else actually hit it, and I can see that it actually got hit. So if anybody wants to go ahead and try, they can basically go to that particular IP address. Oh God, everybody's hitting that thing. So let's go ahead and. All right, good. Let's go ahead and performance test this sucker. Okay. All right. Okay. So so in essence, right? If you have a look at that, actually going from sending out a message, "Hello World," to sending out a JSON payload, and there's actually a C library in the IDF that supports creating JSON files, to going through to something like your SPIFS memory or to your non-volatile storage memory, or wherever you want to go, and actually delivering a full index.html page plus JavaScript plus whatever, not a problem. It's pretty straightforward, okay? But that would obviously bloat this particular code on. So here I've created a server in 41 lines of code using the example connect. Okay? Yeah?
One question.
Yeah.
So after we have registered the handler, can we unregister?
I haven't tried. I'm not sure. Why would you want to do that?
Say for example, if you want to enable a certain URL for a period of time.
Yeah.
And then you move that.
Yeah, okay. I personally would probably handle that logic within the handler itself. And you could always respond with you can respond with anything you want. You can respond with a 404. Or you can respond for 500 or go away or no soup for you or whatever.
Level of redirection where you use a function pointer or something.
Sorry?
So we'll have another layer of
Yeah.
redirection where we have to
Either a function pointer, or what I would personally do is I would basically use something like a free RTOS semaphore or a free RTOS event or something like that, or a group or something like to or queue. Probably the best is a queue, because you get data in and you can basically put that on the queue and you can send that data through to another task. Okay.
I remember encountering the same issue with the Arduino library.
Yeah.
The web server library has a similar thing where you can add a lot of handlers,
Yeah.
but you cannot remove them.
Yeah. So yeah, okay. It's a good question. I haven't tried it. Yeah. So the nice thing with working with FreeRTOS is you basically create a memory stack, and you basically have all this functionality and all that stuff sitting on the memory stack. Okay, and you do all that stuff, and when you decide you don't want it anymore, you basically say delete, and bang, you get all that memory back. So you could potentially just create a server on a FreeRTOS task, right, with all those handles, registered handles in there, and then when you don't need it anymore, just delete the entire task, and then all those things disappear. Yeah, that's right. But I mean, that's microseconds. So yeah, it's not very expensive. Okay. It does, but you've also got the capability of doing wildcard routes in here. Okay, so in essence, what you can do is you can basically say, let's say for example, API/*, and that'll basically take everything that's API, and inside there you can handle whatever you want. Okay, so there are means and ways to actually handle the routes. Okay. What you can find is it works in just out of interest sakes, right? It works from the top down. So if you register this guy first, right, it'll see if it matches, and if it doesn't match, it'll go to the next one. If it doesn't match, go to the next one. So if you got, let's say for example, API, like if you got API / do something specific before the API start, that one will get fired, and then everything else will get caught by the wildcard route. Okay.
So you need to register them in order most specific to
Yes,
generic.
correct. Yeah. Okay. So let's go have a look at the other one, the Platform IO one. So everybody happy with this guy? Okay. As mentioned, this is very minimalistic. I'm not trying to bewilder you with the amazing coding capabilities that I have. I just want to show you something that's really easy to read and see and understand very quickly. Okay. So let's go ahead and create another, open up another project. Right, now what we're going to be doing is opening up the Platform IO one. I've only got 2 more to show, and then after that we can see if we can figure out how to delete the big one, and we can see if we can get everyone's working. And then if we can make it go right, if we can, what it would be really nice, because we're all going to be on the same wireless network and we're all going to be talking the same language, the same network, we can potentially have a couple of guys running as a client, a couple of guys running a server. We could send messages to each other. There we go, on the ESP32. Yeah. Let's see if we can get that to work. I'm not promising anything, but it's quite possible.
Is there a WebSocket library?
Hey?
Is there a WebSocket library?
That would be a... yes, there is. It's unfortunately a little bit low level. It's basically done at the LWIP. And there's a bit of coding involved. But yes, you can do it. Okay. All right, so let's go ahead and have a look at the Arduino. The Arduino side. Okie dokie, so source main.c++. Alright, so again I borrowed this. Okay, so again I'll have to change this. So this is cchs and the password is hackmelb. Alright, so let's have a look at this very quickly. It's pretty straightforward. We set up the serial buffer, we print a whole bunch of stuff, and then we do this Wi-Fi. If the Wi-Fi state is not connected, then go ahead and connect. So essentially, while it's not connected, then just delay. Otherwise, it's going to go ahead and actually try to find an IP address, and then it's going to begin. All right. And this one does something a little bit more practical. And well, I say practical. I'll get into that in a moment. It's got a couple of more lines of code, but it does something a little bit more interesting, which you can very easily do with the IDF as well. What this guy does, okay, is it basically goes ahead and writes a whole bunch of serial ports. It listens. Where does it do that? Client.connected. So it connects, and then essentially a client.reads. Once it's reading, what will actually happen, right, is it's going to basically set up these 2 links. So it's going to print 2 URLs. Okay? And that's what it's going to send up to the browser. And when somebody hits that particular one, what's going to happen is a little bit later, it's going to have a look at that end URL and it's going to say, did the URL ends with an H or did it end with an L? And if so, it's going to basically toggle my LED, my built-in LED on or off. Okay, something very simple to do. You can do that in the IDF very easily as well. Okay. There's a couple of problems with this, but let's go ahead and actually run it. By the way, I must also just thank you to Lan, who basically, I was a bit sort of hesitant of setting everything up with Wi-Fi, and he did a session here not too long ago, and I kind of thought it's actually not that hard based on what I saw. So yeah, thanks for that. Okay, so it's all good. But I do check Platform IO out. It's pretty good if you want to stick with the Arduino IDE. Okay. All right, so we've flashed it. Let's go ahead and actually run the serial monitor. Okay, so we've got a Wi-Fi and we've got an IP address. So let me go through to that IP address. If everybody starts going there, it's going to start going crazy, but let me just have a look at that. So I've got 2 LEDs. Hey, look, somebody's already clicked it on. Okay, so does somebody want to click it off? Click it off. Okay, you guys can have LED wars now. So yeah, okay, so there's on. Okay, let me go ahead and switch it off. There, it's off, then it was on, then it was off. Okay. So, all right, so there you have a very minimalistic Arduino. Did you see that? The little LED. So if I click it off, it goes off. If I click it on, it goes on. No. It's gone crazy.
I can't think why.
It's getting really hammered. It's just a little microcontroller. But believe me, it could probably stand up to all the pressure that you guys are throwing at it quite comfortably.
I got the server running.
You got a server running? Awesome! We got a server running! Okay. We'll get you sorted out, Carl. Don't worry, we'll get you figured out. We'll get you figured out, don't worry. Okay. Okay, dokie. So, that is a client, Esp Idf Arduino. That is a server, Esp Idf Arduino. There's one more thing that I would like to show you both for that, right? And then after that, we're going to switch over to something. We're going to have a look at essentially what's really going on underneath the covers, okay? And you're going to see it's not hard. It's a little bit of code, but it's not hard. And once you understand it, it's actually pretty straightforward, okay? So this particular one is essentially a prelude to the question, how do I get my device out on the market? Because I cannot hard code people's wireless devices inside there, okay? So I need some way for people to be able to input their wireless and then their username and password. Much better than that would be, why doesn't the ESP32 tell me which wirelesses are available? So what we're going to be looking at now is a wireless scan. Okay. So I'm going to close this. And then I'm going to go back to my... Okay, so let me just close, actually. Open folder. So this is going to be the...
I got a question. I got the Wi-Fi, but where did I set up the username and password of the Wi-Fi?
You've got to... Okay, so what you have to do is you've got to go through to the idf.py
Menu config?
Menu config, correct. Okay.
I didn't do that, and it is working.
Because I actually set it up with this Wi-Fi before I pushed it to the gig.
Okay, but where it was stored in the build? Because I clean up the build.
So if you're looking at the... So yeah, so if you... it actually stores it into the configuration file. So if you have a look over here, so the question is, right, where are the username and passwords stored if I basically put them in menu config? That's in the SDK config. So that's essentially the configuration. That menu config actually generates this SDK config over here. This is where you can have all the settings for the ESP IDF.
So SDK config old.
Sorry? Yeah, there's two. There should be an old and there should be another one, the one above that. So this is where it's at. Don't change it in here directly. Doesn't make sense to do that. Rather just open up
just looking
yeah, just open up the menu config, change it, and then that'll create this file. Yeah.
Question. So if you have changed...
Okay, so I'm just going to start because I'm assuming now that I've changed the wireless username and password,
Okay.
I have to rebuild this.
Config example.
This is flash monitor. Okay, so this this scanner is going to take a couple of minutes to build. While it's actually building, let's go ahead and have a look at what the source code says. All right, so just just keep an eye out on that. Okay, so over here I've got a variable right going from the top. Oh, by the way, whenever you're looking at C, probably the best idea is not to actually look at it from the top. But once you've actually sort of look at it and you get a feel for what headers and what variables are included, just go straight to the bottom, because that's usually where life begins with C code, because of the way that it's structured. Okay, so we start off with this particular guy, right, where we do a Wi-Fi init. All right, let's have a look at Wi-Fi init. So Wi-Fi init should not look any different to what we've been looking at before. Wi-Fi init basically initializes the flash, it initializes the TCP IP adapter. Okay, it goes ahead and creates an event loop. All right, and you can see my event loop in this case is I don't care. That's very simple. I don't care what happens, just return OK, it's fine. Okay, so we've got we're basically setting, this is a little bit more interesting. We're basically setting the station mode. Okay, so this is actually new, I just realized. So a lot of the stuff that we were looking at before with the example connect isn't here. So if we have a look at our CMake list, you'll notice that that is the template. That is the default. We don't have any imports. This over here is the makings and the introduction to actually how do I connect. I'm just going to kill this because it's distracting. This is how I connect. So this is, let's not use the example connect. This is ourselves connecting, okay? And this becomes quite interesting, okay? So we basically can say Wi-Fi init, and we basically have this configuration, and we can use a default configuration. And if we basically hover over that, we can see all those various different configurations. The buffer sizes, you know, the various different buffer lengths, you know, whether or not we're going with station or blah, 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 blah. Don't need to worry about any of that. You basically just get this configuration context that, or structure that you require. You basically initialize the structure with this particular line of code. You say whether you want to use a station mode or AP, access point. In other words, do you want the thing to work as its own wireless? We'll have a look at that in a moment as well. And then we say Wi-Fi start. That is all that you need. And in fact, if you really want to know how to basically create a connection, that's all you need. That's everything that you need. That doesn't handle input, it doesn't handle headers, it doesn't handle anything else like that, but it will give you an IP address. Okay, just these lines of code. So what is that, about half a dozen line of codes? Something like that? That's what you need to actually connect. All right, now, once we've actually connected, what I do is I create a FreeRTOS task. So this is essentially just creating a new task with its own stack of memory. I'm giving it 8 kilobytes. And it basically starts in here. All right. So the first rule about FreeRTOS tasks is they never return. They're always sitting in an infinite loop. Okay, so that's why I got the while true. It's the same thing as you can consider it like the Arduino loop. Then what we do is we basically have this thing called scan config, where we basically just put in some defaults, nothing particularly about there. Right? We start the scan and we basically return a structure. Right? We then go ahead and create a whole we pass in the actual configuration structure. Then we create an array of potential SSID structures that we can have out there. Okay, so this over here, if we have a look at this, will hold the information of what a Wi-Fi looks like. Things like channels, things like BSSID, things like things like that. So what is the security that it uses, and so on and so forth. Then over here is just an elaborate, this is where it actually fetches the records, and over here is just an elaborate print that actually just prints out a table. So let's have a look and see what that looks like. It's actually still running, so I'll just monitor it without having to reflash it. That should be quicker. Okay, so it's basically doing all its initialization and actually managed to get a complete list of available Wi-Fis in the area. You can see what communications they are. This one over here doesn't have a name, and the reason for that is hidden. Okay. What's really nice as well is that if you actually have a look and see these particular RSSI, that's telling you the signal strength. Okay, so you can also gauge how far away something is by its signal strength. Sometimes, not perfectly, because sometimes there's things that are bouncing off walls and stuff like that. But in sort of on a very broad shot level, I would say that this one, right, this ESP, somebody's probably got a server over there. It's probably yours. Is sitting closer to me than this one over here, which is Telstra Air, which is actually sitting much, much further away. Okay, so if you consider that you could basically have this as part of your initialization stack when you basically start your program, and then somebody can go through with some menu options on your little display to select the correct wireless, and then essentially we'll give him a chance to put in a password, and boom, Bob's your uncle. Then you can basically connect to that particular wireless. Okay, so there's a Wi-Fi scanner. Okay.
So if it's open, you just pass null strings or empty strings as the password variable.
Don't know. It just means that it's not secure. It might still be password protected, but it doesn't have any sort of encryption or anything else like that. Good day. All right. So should we have a look at very quickly at the other one, and then after that we've got one more one to do. Okay. How are you guys finding this so far? Is it interesting? Okay, good. All right, so lastly, let's go ahead and get this one up. Platform IO. Okay, so open project. So this is the Wi-Fi scan. The nice thing about Wi-Fi scans is I don't have to worry about username and password, so this should just compile and build, and that should be the end of it. All right, so let's have a look at the source code. Okay, same as we've always basically seen before. We basically connect as a station in this particular case. We start the scan, and then this is how they do it over here. Okay, to start the scan, and essentially we start printing it out. That's, I mean, if you have a look at that, they've got this Wi-Fi SSID with this number, and that's pretty much it. Okay. So if you read that code, it's pretty straightforward. It's like they create an array. They basically go out and do a scan. They're not actually saying how many buffers they actually want to use, so they must have some pre-configured buffer behind the scenes. And then over here they say, I want number 1, number 2, number 3 with the SSID and the RSSI. Okay. All of that fancy stuff of let's go ahead and figure all of, the connection and all the stuff happens behind the scenes. So Arduino sort of tries to be a bit of an extra layer on top of that. Yeah, it's broken. All right, I'm gonna have to have a look at that a bit later. All right, so now comes the interesting part. Now this is the part that we've all been waiting for. Let's deep dive into what's going on behind the scenes. Okay, when I say deep dive, it's not such a deep dive. It's actually pretty straightforward, but I'll explain it to you. And once you actually get a hang of it, you should not be scared of it anymore. But to start off, let's have a look at some very, very scary Esp Idf documentation. Right. The process and the drivers that work in front of it. Let's just make sure I've got the right one over here. Station general scenario. There's various different ones. I just want to make sure I've got the right one. AP general. Configure phase, configure start Wi-Fi. Yeah. Alright. That's the access point. Station mode. Okay. So in our ESP program, okay, now I'm going to have to walk between this and this. We'll just walk through it very quickly. In between our, okay, so there's a couple of different players that we just need to identify, and if we understand this, then it becomes very simple. Okay. So in our task, we've got a main thread. That's the one that we're currently running on. It's essentially a FreeRTOS thing. It's a thread that runs our applications. It's a task that we created. Okay. Then we've got this thing called task, which is essentially, let me give this thing to our application. Then we basically have this event task. Now the event is basically that thing that we were looking at earlier on, that event handler. It's basically dealing with switching. What have I got? Have I got data in? Did I have an error in? Did I get some buffer? Did I get a header? Did I get a whatever? All right. Then essentially on this side, this over here is happening internally within the actual wireless drivers. So we've got this LOP task, which is basically another task that happens, and this is going to basically, between this LOP task and Wi-Fi task, they're going to deal with things like IP address, like stack protocol, HTTP stack protocol. They're going to deal with all the low-level bits and pieces. They're going to deal with all the stuff that, luckily, we don't have to deal with. Now, on your typical ESP32, right, specifically something like this with a VRUM, or this chip over here, okay, or even the small little one, or the Pico, whatever, most of these chips have got dual cores. They've got 2 cores that are running. The one core is essentially what we usually use. We can control both cores, but we usually use one core for our application. So the question is, what happens to the other core? The other core is actually being utilized by these 2 guys. Okay? So what that actually means is that while our application is running, okay, we've got another core just dealing with putting together the stack layers, putting together the driver functionality that it requires. All right. So even if our application starts running into very heavy calculations and stops focusing or stops running for a little bit, or because it's very slow, we're not going to disrupt the other core. Now, one of the things that used to happen on the ESP32 which only had a dual core, is that if our application was working too hard while it was connected to the internet, we would get timeouts and would actually kill the connection. And that was the reason for that, was because our application was blocking the threads of what this thing needed to do in order to actually keep the connection alive. Okay, so what actually happens is we, as an application over here, do some work. We then connect. We pass that over through to the to our sort of intermediate to the event task function. That passes that over to the Wi-Fi driver. That then comes back to our event handler to say, I did something. We then take that information and we can do whatever we want with that. We're back on our thread, we're back on our core. We can do a switch statement in there, we can basically call other functions, we can start other processes, we can do whatever we want. Okay? When we basically are done with that, we might need to basically do another call, we might need to basically check a header, we might need to do, so what do? We do another function, we go back to this guy, we say, notify please, it goes back to the driver, which then comes back to our event handler, and our event handler fires a different event. Okay, so there's this communication bridge between us, or our application, and the Wi-Fi driver, and the thing that communicates between the two is this event handler. So if we scroll down over here, we'll notice, okay, firstly we do a whole bunch of initializations, then we basically, and you can see it's all going straight through to this side, yeah? Then we basically go configure Wi-Fi, right? That comes back to our handler, all right? And it basically says, oh, I've started. And that basically goes back to our application. Then we can basically say connect. And it says, okay, I've connected. Now we're back at our event handler, and then we can do whatever we want with the application. Then we can basically say, then what happens is this thing says, guess what? I got an IP. So it basically comes back and we say, okay, we've got an IP. Now we can actually do whatever we wanted. And this is actually the disconnection phase. It says, okay, listen, something went wrong. It went out of range, or there was a problem. It disconnected. Okay. Now, this is an important one if you actually want to write applications. The reason why the Wi-Fi disconnect is important is because that in itself is just an event. But if you want to know why it disconnected, maybe the username was wrong, maybe the password was wrong, maybe the Wi-Fi dropped. Okay, you've got to look at that event and you've got to get the code out of that event, and then from there you'll be able to tell whether or not, oh, the username was wrong, the password was wrong, it had timed out or whatever. Okay, so that's how that works. Okay, but that is essentially the major part of it. Okay, so once you understand that theory, okay, actually having a look at the code becomes pretty straightforward. All right, so I'm going to start building this, and then while it's building, I'll walk you through the code. Okay, I'm just going to keep an eye on it at the bottom, make sure that it doesn't blow up. Okay, that looks good. Okay, so let's go to the bottom, and this is just a single file, so don't worry about it. All right, so we've got this Wi-Fi init. Now this over here should look a little bit similar to what we saw in the scanner. Okay, so if we go to this over here, Wi-Fi init, okay. So this looks very similar. You can see there's a lot of boilerplate coming up here. All right, we've got the initialization for the NVS, the TCP adapter, the event loop. Okay, that all gets configured. We did that in every single project that we looked at today. Okay, this is where it gets a little bit more interesting. This is where we get more control over just using the example connect. Over here, what I'm basically saying is I want to connect as a station. Okay. All right, and then over here I've got some configuration, and the configuration is basically where I can put in the username and password. Okay, if we have a look at this particular structure over here, you'll notice that there's quite a bit that we can do. Let's go ahead and have a look at the station configuration. Okay, we can basically put an SSID, a password, the scan method, what channel do we want to listen to, and so on and so forth. Okay, if we have a look at the AP, which we'll actually get into, well, let's do that later. We'll have a look at the AP stuff later, the access point later. So now that we've actually got that, right, what we do is we say Wi-Fi start, okay? And that's pretty much it. This is a semaphore that's basically going to say, all right, once you've started, then go ahead and handle whatever you're doing. But that's pretty much it, right? So I've got this commented out code, which we'll have a look at in a second. But you can see that actually connection is just about a dozen lines of code, just maybe a bit more than that. All right. The important part is this thing over here, this event handler. Okay. And this event handler is this thing over here. So you can see over here. All right. So remember that so Wi-Fi lip init, event handler, and this is it over here. So this is essentially the bridge between what our application is doing and what the Wi-Fi driver is doing. So it starts off, when we basically say start, we say start over here. ESP Wi-Fi start. The first thing it's going to do is it's going to basically go out and it's going to call this event handler. Okay, and it's going to say, I'm starting. Then we can say, all right, now that you're starting, go ahead and connect. Luckily, that's the only thing that we really need to intervene with, okay? Then it goes back to the Wi-Fi driver. Wi-Fi driver basically comes back in here, right? And it can go, well, I disconnected, or sorry, I've connected, or I have an IP address, or I disconnected. And over here is where you basically get the other reasons out. So if you have a look at this guy over here, you can see that there's a couple of different things that you can get. So just to show you what that looks like, just quickly, we can say event.disconnect.reason. So that'll give me a reason why it disconnected. Okay, so that's how you can debug things. Okay, all right. And then once that's done, okay, then that's pretty much it. What we can do at this point in time is once we've actually finished connecting, we can call a semaphore, okay, and that's going to basically wait for us. So let's go ahead and give this a try. So so you can actually see it's running at the back because I actually did a flash monitor. We can see that we've actually got an IP address. So just to give you an idea what this application does once it's actually finished connecting, because that's all we looked at. All right. So after that, right, it's going to call this particular semaphore. So unconnected is going to come in here, and this should look very familiar. We basically set up an endpoint. We say when we get something, we basically trigger a handler, and here's our handler. So exactly the same code that we saw before. So this is just a server. Okay. Of course, if I wanted to create a client, you saw that's about 3 or 4 lines of code, not a problem. So let's go ahead and actually try this out. You've already got there. Okay, Control V. But what's important and what might be interesting to see is actually just going up a little bit while we were actually running this. Okay. What you could see is things like connecting, connected, got IP. These are messages that I'm printing out inside this event loop. And this is where you can have fine-grained control. Okay. All right, good. So so over here, you want to basically get your SSID. At the moment, I'm getting it from my config. So that was the other question that I'll just basically show you very quickly. How do I basically change the SSID, or what if I want to actually build in more things like that? You'll notice over here in this particular project, I've got this thing called a kconfig. Now I could do a whole session just on this. This is essentially a file that defines custom menu configurations for the Esp Idf. Over here you can see that I've set up a thing over here called Wi-Fi SSID, Wi-Fi password, and over here you can see that I give place for that. And the way that that interprets itself is, if you have a look at the top of the file, config Wi-Fi SSID, config password. So if I come into, if I just copy this, copy path, open up my Esp Idf and cd into this directory, and then I go idf.py menu config. You can see over here I've got this Wi-Fi connect, And over here you can see I can put in the SSID and the password. Okay. So that's how that works. Of course, I can overwrite this directly in the code if I so desire to. If I wanted to just hard code it for whatever reason, I could do that over here as well. Okay. Now, the one thing I'd like to show you before we sort of do anything else is we've spoken about everything that we've done up until now is the ESP32 acting as a station. It's connecting to the CHS Wi-Fi. Okay. So let's change that around a little bit. Okay, so let's see what's involved. I'm just going to comment this out. And let's uncomment this lines of code over here. Okay. This is me creating my own access point. All right? And as you can see, it's pretty damn straightforward. I have an SSID, I got a password, and unfortunately, I can only basically do a maximum of 4 connections. So, the first 4 that gets in there is going to win. Okay, and then somebody else will have to drop out before it actually, connects to somebody else. Okay, now over here you can basically go into this particular definition, and if you wanted to set other things up, let's just go through to AP. You could basically, set up the channel. You can set up the auth mode, which could be soft app, auth web, soft whatever. You can make that hidden. You can basically say how many max connections, but the max number of stations is allowed to connect as default is 4. I don't know if it actually works more than that. Honestly, I haven't tried. Maybe you can set it higher. Okay. And then, of course, the beacon interval, which is essentially how long it's polling out just to say, I'm alive, keep on talking to me. Okay. So, coming back to this guy. Okay. Right. So if I can this, all right. So what I'm going to do is I'm going to flash it with this. All right. Do I have anybody over here?
So you should.
Yeah, you can actually do a Wi-Fi scan to see it. That's true. But I'll show you how this works.
What's the password?
Okay, good. Okay, so the password. Okay, we can see that somebody's trying to connect to it. So just out of interest sakes, I haven't put them all in yet, but this is important. These events over here will also show you station events. Somebody's connected to me, somebody's disconnected to me, whatever.
So
okay.
The password is freezing the screen because I see some.
Okay, so the password is P at SSW0ID. Oh, okay. So my computer actually disconnected to it, which is why you lost your screen. Let me just get that back.
Is it because it did connect to?
No, it's automatically connected to the ESP. Okay, I was wondering who connected. It was me. Okay, check this out. Right, you got an IP address. I've got a couple of guys that are connected. Okay, now what the guys that are connected, the guys that are able to connect, go to 192.168.4.1.
4.1 is a gateway.
Yeah. You got a hello world? Yeah, okay, so you connected to the wireless. Okay, now open up a browser and go to 192.168.4.1. Let me see if I can connect.
Yeah, hello world.
Hello world, you got a hello world.
Yeah.
So there he's been able to connect directly to the device on his phone. Okay, so let's have a look and see if I can get Visor to work. Oh, there we go.
Richmond.
Which way?
It's much bigger than ours.
So if you go in the.
Yeah, now I can do that, I can do.
Yay! I got it working. Man, look at that font. It's tiny. All right, guys. What did you think? Was that overwhelming, or was that good, or was that awesome?
Mine's different.
Okay, cool.
Set up follow the
all right, good. So let me spend 5 minutes fixing the Git repo, deleting the build directories out of that, and then hopefully you should be able to pull it down, and then you guys will get the source code.
Because
mine. If you guys will need to have the IDF set up on that. My course is so close to being finished. I know I say that every time.
Okay.
But I'm going to launch it this
Maybe.
like in the next little while.
Okay.
Yeah.
So
No.
IDF